Hello everyone and welcome back. So this time we're going to be going through a group problem. So if you've got a friend, work on it together. If you don't have any friends, make a friend. Okay, so how's this look? Well, we have a 400-pound crate, which we see right here. And it's supported as shown. It's in equilibrium, it's not going anywhere. We got two ropes, and as we know, ropes are always pulling, so they should be applying forces in this direction. And we have a pole, which, well, it can pull or push, so we don't quite know what direction it's going to go. What we want is the magnitude of the tension in each of the cables, okay? As well as the force that's developed along the strut, AD. Now how are you going to do this? Well, you're going to draw a free body diagram. And then you're going to solve for FB, FC, and FD by getting those force vectors in their Cartesian form and solving using your equilibrium equations. You got three equations, you got three unknowns, you should be able to solve it. So go ahead, take a minute, pause, and then come back here and we'll do it together. Okay, so 3, 2, 1. By this point, you should have paused, so hopefully you've gone through it, you've run some issues, or maybe you did it all fantastically. Either way, you can check it here. So let's watch it. First, our free body diagram. In this case, we went ahead and said FD was pushing. This makes a lot of sense because both FC and FB are pointing in the negative y direction, and we would need at least one force that's pushing in the positive y direction, because the weight is in the z direction only. Now, we need to get these force vectors, and what we do is we get the unit vector for each of them, and then multiply that by their unknown force magnitude. Now, these unit vectors are pretty simple to get. The directions are fairly easy. Just be very careful about your signs, because you're starting from A and going to some other point each time. So even though this right here, this point D is the origin, you can see that when we look at our force vector, we have 12 in the J direction and 5 in the K direction, which is up. Oh, sorry. Now, one question you might be having there is like, well, wait a second. You said I was going to have to be very careful about my signs, but these are both positive. And you are correct. They are positive. So where did that come from? Well, let's keep on looking at it, and we'll come back to that in just a second. So for the AC vector, it went 2 in the x direction. We have a positive 2 there. It went 6 in the y direction, or sorry, negative 6 in the y direction. So we have negative 6. And then went 3 in the z direction. Now you don't see that right away. You see a 5.5 here, but be very careful because it's 5.5 minus 2.5, not 5.5 just by itself. It's the change in position. It's 1 point minus the other. So be very careful about that. That's where we get our 3 from. And I think I've got probably enough writing on here. Let's get rid of that. And our magnitude simply comes from Pythagorean theorem in 3 dimensions. Okay. And continuing onward, this one also makes sense. We have a negative 4. It goes from A to B. And that's in the x direction. You see it's moving in the negative x direction. We have a negative 12 for the y direction. And we have a 3 for the z direction. So let's break that apart, because you might be noticing like there's no 12s anywhere here. Like, this doesn't actually make much sense. Where is that coming from? Well, where is it coming from? It's coming because we went 2 in the x, actually, not 4. We went 6 in the y, and we actually go 1.5 in the z. Because we go from 2.5 feet to 4 feet. And what they're doing here is they're just making it easier on themselves and multiplying everything by 2 to get a nice round number. And they can do that because it comes out in the magnitude. The magnitude gets bigger, and it will, in the end, be the right thing. Now, finally, we got to come back to AD and figure out what's going on with this one. Why is this one so strange? And is there an issue with it? Is there an issue? Okay, now here is why this one is positive when the other ones were negative. Well, this is one goes from D to A. all the rest went from A to something else. It's because of how we drew it. Notice that force D is pointing towards point A, while force C and force B are pointing away from point A, and that's why we did it differently. Okay, now if you sum these all as vector equations, you'll get 0. If you break them up into their respective scalar equations of equilibrium, sadly, you're going to have some math. There's going to be some algebra here. It's no fun. Nobody likes to do algebra, but you got to do it in this case. My advice is probably to solve the one that has the least unknowns first, and then start plugging it in. But in the end, there's not really a super good way of getting rid of all this. So if you know how to use your calculator, how to program matrices into a calculator, this would be a good point to use that. You could probably solve it fairly simply. If you don't know how to do that, this might be a good place to learn. Other way, it's just a little bit of algebra. Be careful as you go, and you will get the right answer. So from this, we get that force B is 274 pounds, force C is 295 pounds, and force D is 547 pounds. So, I hope this helped you. I hope you enjoyed it. And I'll see all of you next time. Have a good day. Bye-bye.